In today's tutorial, we're going to have a review about activation functions. So, let's talk about why linear model fail. Okay, the lesson starts by the showing why a linear model breaks down when a real-world patterns becomes complex. In the deliveries example, travel time does not increase at a constant rate as distance increases. Short distances, then city traffic are slow. Medium distances, transition traffic. Long distance, highway faster. A linear model assumes every mile adds the same time, so it can only produce straight line which cannot capture these changing conditions. Number two, adding more neurons is not enough. You might think adding more neurons automatically solves problem. However, if neurons only perform linear operations with plus bias, and stacking them still results a linear overall. Even with the hidden layers, a network made purely linear transformations cannot learn curves. Role of activation functions. To learn nonlinear patterns, the model needs activation functions. A neuron now works in two steps. Compute linear transformation, like for example, z is equal wx plus b, pass results through activation functions. This small nonlinear step slows the network to model complex relationship instead of straight lines. So we have the ReLU or rectified linear unit. ReLU introduced as the most important activation function in modern deep learning. If input is less than 0, the output is 0. If any greater than equals 0, output is equal to input. Why ReLU works? Simple and fast to compute, introduce bend in model, avoids many issues found in older activation functions. With ReLU, negative values flatten to 0, positive values follow a straight line. This creates a corner breaking linearity. Where the bend happens. The bend occurs when wx plus b is equivalent to 0, which is x is equivalent to where x is equivalent to negative b over w. Each neuron has its own weight and bias, meaning each neuron activates at a different input value. Each neuron had a bend differentiation. So number 6, multiple neurons equal multiple bends. By using several neurons in a hidden layer, each neuron activates at a different distance. Their outputs combine in the next layer. The result is precise wise linear approximation of the curve. Without enough neurons, the network approximately any smooth, including complex patterns. So, yeah, multiple neurons equal multiple bends. By using several neurons in a hidden layer, each neuron activates a different distance. Multiple By-torch model structure, you only define layers, compute activation functions applied between layers. First linear layer, input distance, output layer neurons, real activation applied element-wise. And we have other activation functions like sigmoid, output between 0 and 1, mobilities, like that. So our key takeaways, linear models cannot learn curve relationship. Hidden layers alone are not enough without nonlinearity. Activation functions enable neurons learning. Multiple ReLU neurons can approximate complex patterns. ReLU is fast, effective, and resistant.